Hello, beautiful chemists, and welcome back to the 2025 AP Chemistry exam, specifically now FRQ number 6, which is a short form FRQ, 4 points, and these tend to be quick hitting and designed to take you about 7 to 8 minutes. This one is focused on Unit 9, specifically galvanic cells. Haven't seen those yet in the FRQs, but this is all 4 questions based on galvanic cells. So hope you're ready to have a little fun, and let's get started. As promised, question 6 begins with a galvanic cell that they've drawn nicely for us, along with 2 half reactions and cell potentials down below. Let's read the prompt. A scientist constructs a galvanic cell as shown in the diagram. As the cell operates, the zinc electrode increases in mass and the aluminum electrode decreases in mass. A data table with the standard reduction potentials for the substances follows the diagram. Great. Prompt A, write the half reaction for the oxidation that occurs at the anode. Okay, so I have to figure out which of these two is the anode where the oxidation is going to be coming from. And we have 2 reduction potentials, but one of them needs to be reversed. So there's 2 ways to get at this question and figure out what's the half reaction we need. The first is to look at the clue that they gave us. They tell us that the zinc electron increases in mass and the aluminum electrode decreases in mass. That tells me that the zinc ions are being deposited onto the zinc electrode, exactly as written down here. So that tells me that the zinc is being reduced, not oxidized. And if the aluminum electrode is decreasing in mass, that means the aluminum atoms are becoming aluminum ions off here in the rest of the anode. And so the aluminum has to be oxidized. You could also have thought about it mathematically by looking at these 2 values, knowing that these 2 have to add up to a positive overall cell potential if this thing is a spontaneous cell, which it is. And so we need to then flip this bottom one to get a more positive overall cell potential. And so therefore we just reverse this half reaction to make aluminum, making aluminum ion and those 3 electrons. So if you put that on your AP Chemistry exam, you can pat yourself on the back knowing you got that one correct. Part B, write the balanced net ionic equation for the overall reaction that occurs in the cell. Okay, so now that we know that this is still being reduced and this is being oxidized or flipped, now I can go ahead and write the overall balanced equation as shown here. So aluminum becoming aluminum 3 plus, zinc becoming zinc atoms on the electrode. Now you also might notice that I put a 2 and a 3 and a 2 and a 3 there, and they don't appear anywhere here. So what's going on? Well, the number of electrons that is given off by the anode has to equal the number of electrons being accepted by the cathode as it moves from right to left. Therefore, we have to find the least common multiple of 2 and 3, which is 6. 6 electrons need to be transferred overall, and so this one has to be doubled, this one has to be tripled, and so I multiplied them both through to get those electrons to cancel. So 2 and a 3 and a 2 and a 3 are your coefficients. Part C involved a little bit of stoichiometry and math. And the prompt says, initially, each electrode has a mass of 50 grams. The cell is allowed to run for a period of time and then stopped. Which electrode's mass changed the most? Justify your answer with a calculation. So what I have to do is I need to find the mass of both that's either deposited or dissolved. And I first thought to myself when I was doing this at home, fun fact about me, as soon as the FRQs come out, I hit print and I run to the printer and I grab them. And usually I don't have time at school, so I bring them home and I sit at my kitchen counter, grab something to drink and eat as a snack, and then I do take the test myself. And I initially thought, let's use 2 moles of aluminum because there's a 2 in front of it in the balanced chemical equation. But then I realized 2 moles of aluminum is going to weigh 54 grams, which is more than the mass of the electrode to begin with. So I had to correct myself. Let's use 2/10 of a gram and 2/10 of a mole and 3/10 of a mole, and change them both to grams. And if 2/10 of a mole of aluminum react, that means it's going to change by 5.4 grams. And at 0.3 moles of zinc, at 65 grams per mole, 19.6 grams of zinc. And so the zinc electrode has a greater change in mass. Okay, last one. This is a tricky one. The standard zinc aluminum cell has a value of E cell equal to 0.9 volts. Great. The scientist needs a galvanic cell that produces a greater voltage. The scientist has access to the chemical systems in the table. If the scientist uses the zinc half cell as one of the other options from the table, what is the maximum voltage that can be generated under these standard conditions? Okay, tricky here. Because at first you might be kind of thinking the same way as you did in the previous prompts. And you think to yourself, oh, negative 0.76, what if I use one of these three? This one being the most negative, and just reverse it and make that be oxidized while this is being reduced. You would get a value of 1.09 volts, which is a little bit bigger than the 0.9 volts that is there. But to get the question fully correct, we actually have to sort of back off a little bit and say to ourselves and remind ourselves that zinc electrode does not need to be the cathode. It's great if it is. It doesn't need to be. The electrons will spontaneously go one way or the other. And if I get rid of the idea that the zinc has to be the cathode and think, what if it's the anode instead? Then I get a better option. Because if this is the anode, this will get reversed to a positive 0.76 volts. And if I match that up with the gold electrode, which already produces 1.5 volts, a positive, and add those two up, I will actually get a voltage for that cell of 2.26 volts, which is the highest voltage out of any of the combinations that you can get there that include zinc. So that was a little tricky. You had to sort of, reason your way through it and take yourself out of the box for a moment to get that. But hopefully that made sense to you, and hopefully that's what you put on your exam. You can congratulate yourself if you did. Well, that was question 6 on the 2025 AP Chemistry exam. I hope you found this description helpful. You can always leave me some comments or some questions down below. And in the meantime, happy studying and have a great day.